Hello everyone, I'm Kelvin L. Pabie. Welcome back to SM Academy. Today we'll be solving question number 3 on a normal stress. It says a rod is composed of an aluminum section rigidly attached between steel and bronze sections as shown below. Axial loads are applied at the positions indicated. It says if P is equal to 3,000 pounds, and the cross-sectional area of the rod is 0.5 inches square. Determine the stress in each section. This is the rod given us. So in order for us to determine each of the stress in this section, we have to draw the free body diagram of each section. So now let us start with the steel. So we draw the free body diagram for steel by cutting section through the steel. So the free body diagram goes like this. So this is the free body diagram for the steel section. So the free body diagram shows the internal forces to external force. So in order for this steel section to be at equilibrium, we have to draw the force opposite to this external force. So now, in order to find the force, we have to take the law of equilibrium, saying summation of f of x is equal to 0. So we got the first force, which is 4. P is negative because it's rolling in the negative direction. Got plus the force in the steel is equal to 0. But we know that P is equal to 3,000 pounds. So say minus 4 parenthesis open. We substitute 3,000 for P and 3,000 pounds plus force in the steel is equal to 0. So we have 4 times 3 equals 12. Add a 30 there, give us 12,000 pounds plus force in the steel is equal to 0. But we have to send the 12,000 across. So we got the force in the steel to be equal to 12,000 pounds, or force in the steel is equal to 12 K. So we have gotten the force in the steel, but we are told to find the stress. Modular stress is equal to the force divided by the cross-sectional area. Modular stress in the steel is equal to the force in the steel divided by the area in the steel. So come on, say the force, the stress in the steel is equal to the force in the steel now is equal to 12 K, 12,000 pounds divided by the area is given to be 0.5 inches square, 0.5 inches square. So we got the stress in the steel to be, we use our calculator, we know that 12,000 divided by 0.5 is equal to 24,000. 24,000 pounds per inch square. But we have to convert this to kilopound per inch square. This is pound per inch square. So we have to convert to kilopound per inch square in order to make the answer short. So then we know that 1 KSI that 1 kilopound per square inch is equal to 1,000 pound per square inch, which is PSI. So when we convert that, we get stress in the steel to be, we take decimal point 3 places to the left, 1, 2, 3. We get 24 kilopound per square inch, KSI. But know that this 24 is the same as 24,000 PSI, which is pound per square inch. So convert it to kilopound per square inch, which is KSI. So this is the stress in the steel. Now let us find the stress within the aluminum section. So first look cross section through the aluminum section. Draw the free body diagram. So this is the free body diagram for the aluminum section. So in order to find the force or the stress within the aluminum section, we have to find the force that makes this rod as equilibrium. So this summation of F of X is equal to 0 because these are all axial loads. So we'll start with minus force P plus force in the aluminum section is equal to 0. So we get minus 4. We know that P is equal to 3,000 pounds plus the force in the aluminum section is equal to 0. So we get minus 4 with times it. Minus 4 times 3,000 equals minus 12,000 pounds plus the force in the aluminum section equal to 0. So when we send it across, we get the force in the aluminum section to be 12,000 pounds, or force in the aluminum is equal to 12 K. So now let us find the stress. We know that the stress is equal to the force divided by the cross-sectional area. So we have the force within the aluminum section. We know the area is 0.5 inches square. So we got the stress within the aluminum to be equal to the force in the aluminum is 12,000 pounds divided by 0.5 inch square. So when we solve this, we'll get the stress in the steel to be 24,000 pounds per square inch. which is stress in the steel, to be equal to 24,000 psi, which is pound per square inch. We want to convert this also to kilopound per square inch. So know that 1 kg is equal to 1000 kilopound per square inch. 1 kg is equal to 1000 psi. So if we do that, we get, we take our decimal point 3 places to the left, 1, 2, 3. So the stress within the aluminium section will be equal to 24 ksi, which is kilopound per square inch. So this is the stress within the aluminium section. So finally, we are now coming to find the stress within the broom section. So when we cross section through the brooms and draw the free body diagram for the brooms. This is the steel section. This is the aluminium. This is the force within the brooms. So this is the steel section, the aluminium section, and the brooms section. So in order to find the force, the stress within the brooms, we have to find the force that makes this bar an equilibrium. So we got the summation of f of x is equal to 0. We got force adding the left direction, which is 4p, plus force adding the right direction, plus the force that make the bar equilibrium, with the force at the brooms, is equal to 0. So we got minus 4. We know that P is equal to 3000. So we get P equal to 3000 pounds, plus another force, which is 3000 pounds, plus force in the brooms is equal to 0. We know that 4 times 3000 again 12,000 pounds, minus 12,000 pounds plus 3,000 pounds plus force within the brooms is equal to 0. So we got 12,000 times 3,000 plus 3,000 rather is equal to 15,000. I'm sorry, we are subtracting here because the sign at opposite. We got negative 12,000 pounds and we got plus 3,000 pounds. We subtract and the greater number carry the sign. So I'm sorry, it is not addition. So we got 12,000, got 12 minus 7 to the right. Okay, 9,000, so it's minus 9,000 pounds plus force in the brooms is equal to 0. We send that across. We get force in the brooms to be 9,000 pounds or 9K. So now we have gotten the force that makes this bar at equilibrium, which is 9,000 K. So now let us find the stress within these brooms. So that the stress within the brooms is equal to the force in the brooms divided by the cross-sectional area in the brooms. So now we get the stress in the brooms to be, the force is 9,000 pounds divided by the cross-sectional area, which is 0.5 inch square. So that we get stress within the brooms to be 9,000 divided by 0.5 is equal to 18,000 pounds per inch square. So I have to reduce this answer to one of the prefixes. We know that 1 kg is equal to 1,000 pounds per square inch. So when we take our decimal point 3 places, we get stress within the brooms is equal to 18 KSR, which is kilopound per square inch. So this is the stress within the brooms. Thank you for watching. Please don't forget to share, comments, subscribe, and share. Thank you.